amount of water equals to total capacity minus current water. Okay, what is the total capacity? This is a prism. It has a uniform cross-sectional area. So if I want the total volume, how much work? What is the working for that?
The volume is the C part 1.
C part 1 is the current amount of water. This is C part 1. But what about total volume? Semicircle times length, right? So when you mention area, are you talking about area of semicircle? Okay, so area of semicircle, half times pi, radius 30 square. This is the cross-sectional area. Is that the volume? No, what must I do to this area to get a volume? No, from area to get volume. Okay, what do you mean by height in this case? Where is our height? Value. No, that is the radius. Huh? What? cm or meters? Oh, okay. So 1.5 meters to cm, right? So 150 cm. Then minus your answer in part C, part 1, which is, how much is it? 309.75 times 150. Then you get the amount of water required. So that is approximately 170 liters. Because they want you to correct answer to the nearest 10 liters. Wake him up. Okay? Question 9. Second last question. Anybody needs help? 9?
So the 150
150 is the length.
the from 1 to this one.
No, read the question again. The length, 1.5 meters. Cross-sectional area times the length. 1.5 meters. Okay, we're now at question 9. Anybody needs help? Look at your work. Make 2 comments. Oh, okay, wait. Before that, 9A part 3. Make 2 comments. Do you need help? Whenever the question asks you to make 2 comments or make 2 statements, whatever, there will always be 2. What do they want you to compare?
The median
Okay, median.
and the range.
Median tells us the performance. Okay, next one will be your IQR or your standard deviation. This tells us consistency. For our statistic questions, we always compare these 2. I have never ever seen a question that requires us to compare anything else. Okay, mean, we can also use mean instead of median. We always talk about performance and consistency. Do you know how to determine which one has a better performance? In this context, it is on the speed limit. So we've got speed of cars in the morning, speed of cars in the afternoon. What does the median therefore give us when we talk about performance? You see, for the morning, median for morning equals to 9A part 1 part A. The answer is 42 kilometers per hour. Median for afternoon equals to how much? 40. So what do we get when we compare these 2 median values? What is the conclusion? What is your interpretation when I say performance? Average? No, we don't use the word average. Faster or slower? Yeah, okay, that is a comparison of the performance. Generally, morning or afternoon faster? generally, cars in morning move faster since median morning greater than median afternoon. Okay, so you state down the values, then you write down the statement. Any questions? Quite simple, right? So that is the performance. I write down the word generally. Why is it important to have this word? Yeah, not all cars are faster. Some are faster, some are slower, right? I definitely have some cars in the afternoon which are faster than the cars in the morning. But generally, overall, the overall performance, generally, cars in the morning are a bit faster. Next thing, for our consistency, we're going to compare the interquartile range. For I, you are supposed to spell it out, IQR, morning. We have, how much is it? 9 kilometers per hour. Interquartile range for the afternoon. Eight kilometers per hour. Okay, based on these two, you're supposed to talk about consistency. So right now the values already, then what are you going to tell me about the consistency? In the question it says one morning. Then at the bottom it says one afternoon. Okay, so which one more consistent? Afternoon, okay. Cars in afternoon. You cannot just say afternoon more consistent. Cars in afternoon are traveling at a more consistent. This is the keyword, speed. As IQR afternoon less than IQR morning. With this, you will get your 2 marks. Not difficult, very standard type of question. Most study will come out for a mid-year. So what do we need to compare? Median and interquartile range. What does the median tell us? Performance, whether who is faster, who is smarter, who is heavier, whatever. Interquartile range or standard deviation, they tell us consistency. The smaller the, not better, the smaller the, more consistent. Okay, now for part B. On probability. Who needs help for part 1? Part 1? Okay. One of the cars selected at random, find the probability as no passengers. So out of, how many cars are there? 80 cars. Out of 80 cars, some cars have no passengers, some cars have 1, 2, 3, 4 passengers. How many cars have no passengers? 34 have no passengers. Out of how many? 80. So if I randomly choose, is it likely that I'll select somebody with no passengers? Is it a half-half type of probability? No. So probability more or less than half? Less. How do you know it's less than half? Because only got 34 cars, 34 or 80, right? So the probability is simply 34 over 80. Then you simplify to get 17 over 40. Part 2. Part A. 2 cars are selected at random. Can I select the same car again? Can or cannot? Cannot. I select, then it's out already. Find the probability that both had 4 passengers. So probability both have 4 passengers. For this to happen, the first car must have how many passengers? The first car must have 4, right? And what is the probability of selecting the first car with 4 passengers? 5 over 80. This is my first action. I choose a car that has 4 passengers. There are 5 out of 80. So that car is taken out of the picture already. Then the second car, what am I wanting to have? 4 passengers again. Out of the remaining cars, how many have 4 passengers? Out of all the remaining cars, how many cars are there? 79. After 80 cars, you take out 1 car already, right? How many cars left? 79. How many out there have 4 passengers? Originally 5, you take 1 out, left 4. 4 out, how many? 79. Okay, so here we simplify. This becomes 40, this becomes 2. We get 10 over 79 times 40. 316. Oh, no. This one is 80. This was 4, cancel 1, this becomes 20. 1 and 4. So we get 1 out of 4 times 79, which is 316. Okay, now part B. One had more than 2, the other had fewer than 2. Probability, one had more than 2, the other had less than 2, fewer than 2. Okay. So, what is this scenario right now? Out of 80 cars, you get to choose, right? What would you like to choose as your first car? More than 2 or fewer than 2? Your choice, the first car. Sophia, you want fewer than 2? Okay, what is the probability of choosing the first car fewer than 2 people?
17.
Is it only 17?
17 plus 34.
Okay, 17 plus 34 divided by 80. This is the first car fewer than 2 people. Then you need a second action, right? Your second action, you are choosing a car that has more than 2. So how many such cars are there?
11 plus 5.
11 plus 5. Do we multiply or do we add? Do we multiply or do we add? Multiply, because it is a n. First car less than 2, n. So I multiply. Second car more than 2. So you're telling me that it is 11 plus 5 divided by how many cars remaining? 79. Okay? Because you take 1 car already, so less 79, right? Okay, Sophia?
Yeah.
Now this scenario that I've just shown you over here is first car fewer than 2. Second car more than 2. Correct? Is this the only way to do it? Is this the only way? First car fewer than 2, second car more than 2. No, what is the other way? This is already first car fewer than 2. First fewer than 2. Second more than 2. Okay, what is the other option? Okay, first more than 2. Second less than 2. Right? So do we add or do we multiply? Okay, inside here we can write them down easily first. First one more than 2 means 11 plus 5 over 80. Second one less than 2. 34 plus 17 over 79. Okay. These are the 2 cases. Is it this case and this case, or this case or this case? Is it an and or or? Or. So if it is an or, we use a plus or a multiply. Plus. Okay so far? Inside this bracket, the value, is it the same as the value inside here? Yes, they are. Can see that, Sophia? Do you see inside these 2 brackets, the values are the same?
Yeah.
Working different, but the final answer is the same, right? Because denominator times denominator, numerator times numerator, they are the same. So we simplify it to become 2 times of 17 plus 34 over 80 times 1 plus 5 over 79. Because for this question, we know in our minds, first case, whether it's first car less than 2, second car more than 2, or the second case, first car more than 2, second car less than 2, they are equivalent. They will give us the same answer. So usually we put it this way. We usually skip this step. But if you need them listed clearly out, then here is the full working. And you get the answer. Any questions? Hang on, any other questions? If not, this is the end of this paper. Oh wait, there is one more. Question 10. Okay, Sophia, what's your question? Okay, talk to me later. Huh? One last one. 10A. Can do or cannot do? Can do or cannot do? Can Part B. Can do or cannot do? Yes, got plus minus. Plus minus how much? I don't know. Okay, just be as accurate as you can. Part B, anybody needs help? No? Okay, part C. Part C, need help? Need help. First, for part C, time taken. We need to find that. Time for 3 jogs equals to the time, 3 times the time for one jogging session, right? So if I want the time, I take the distance divided by speed. What is the distance? We found from 10A. Distance is 5.5 kilometers. So 5.5 divided by the speed, 9.5. So we get our answer in time. 104.21 minutes. So this is the time taken for 3 jogs. Does she meet the time required for vigorous exercise? Yes, she does. This is more than 75 minutes. So we answer the first part. Yeah, she'll meet the target for time. Target for time is met. Okay, the next thing. She thinks that she will use more than double the amount of calories. Is that true? So let's find out. Amount of calories used. Amount of calories for 3 jogs equals to jogging at 9.5 kilometers per hour depends, the amount of calories you burn depends on your body weight. The higher your body weight, the more you burn. For her, 70 kilograms. She is burning 345 calories if she is jogging at 9.5 kilometers per hour, and this is for 30 minutes only. Okay, so how much time is she jogging? Then we'll be able to find out how much calories she's burning. So 30 minutes, burn 345 calories. If she's using 104.21 minutes, then she'll burn 345 divided by 30 times 104.21. Okay? So this amount of calories, and that will be 1198.4 calories for 3 jogging sessions. Then we're going to find out the amount of calories for 3 walks. Okay, for 3 walking sessions, she's going to burn 150 calories over 30 minutes, but the time taken will be how much time? 152. Because earlier we calculated 152 minutes. Did we? Yeah, we did. So multiply by 152 and we get the answer for calories used in 3 walks, 761.54. So the question, is she using double for the run compared to the walk? Is it double? No, she said more than double. Did she use more than double? How do you decide if it is more than double or not? Just divide lah. 1198.4 divided by 761.54. We realize that it's actually 1 point something only. So it's less than double. Since 1198.4 is not more than double of 761.54, then she is wrong. That's it.